When you think about Cold War bunkers, what comes to mind are steel doors, reinforced concrete, and hidden entrances. But you know, the most insidious threat these underground facilities faced wasn't enemy bombs. It was water. Moisture, whether from groundwater seepage, condensation, or humid air, could destroy electronics, corrode structural steel, and turn a life-saving shelter into an uninhabitable space. Engineers quickly realized that preventing water infiltration was as crucial as blast resistance, giving birth to sophisticated moisture management systems that are still relevant today. At the heart of this invisible defense were vapor barriers, lead-lined membranes, and capillary breaks, techniques that quietly protected entire facilities from the hidden enemy beneath the earth. Understanding how these systems worked not only gives insight into Cold War ingenuity, but also provides practical strategies for modern underground construction, off-grid shelters, and historical preservation projects. Understanding why vapor barriers became the first line of defense is key. Vapor doesn't behave like liquid water. It can permeate concrete, seep through wall joints, and condense on cold surfaces where sensitive equipment or living quarters are located. In the Cold War, engineers realized that even small amounts of moisture could ruin electronics, corrode steel, and cause structural issues. To prevent this, vapor barriers were installed on floors, walls, and ceilings to create a continuous layer that blocked moisture from entering. These barriers were typically made of reinforced polymer sheets, asphalt coatings, or other impermeable materials. For anyone constructing an underground facility today, replicating this is straightforward. Install continuous sheets across all subterranean surfaces, sealing seams with tape or heat welding. The goal is to stop vapor at the source, ensuring the interior environment remains dry and functional. Exploring how lead-line membranes protected critical areas is fascinating. Lead may seem like an odd choice for moisture protection, but Cold War engineers recognized its unique properties. Beyond shielding against radiation, lead is completely impermeable to water vapor. Thin sheets of lead were integrated into membranes around sensitive rooms, such as command centers, power control rooms, and communication hubs. These lead-line membranes formed an unbroken envelope, preventing both moisture and vapor from reaching critical infrastructure. While modern builders may not need lead, the concept remains highly relevant. Use impermeable membranes around sensitive areas to create a secondary layer of protection. By applying heavy-duty waterproof sheets or synthetic membranes in targeted zones, you replicate the Cold War approach on a smaller, safer scale. Learning how capillary breaks stopped groundwater from creeping into structures was really a game-changer. Moisture doesn't always enter as liquid on the surface. Capillary action actually allows water to move upward through soil, concrete, and other porous materials. Engineers discovered that even well-drained sites could experience rising damp that compromised floors and walls. So, to counter this, capillary breaks were incorporated beneath slabs and around foundations. Layers of coarse gravel, drainage mats and impermeable membranes disrupted the movement of water, preventing it from travelling upward into critical areas. In modern underground projects, this principle is, honestly, essential. Placing a gravel layer beneath the slab, combined with a vapor membrane, creates an effective capillary break that protects the structure from long-term moisture infiltration. Understanding how layered moisture protection ensured facility longevity really highlights the genius of Cold War moisture engineering. It wasn't in any single solution, but in the combination. Vapor barriers blocked airborne moisture, lead-lined membranes protected sensitive zones, and capillary breaks stopped rising groundwater. Together, these layers created a near-foolproof system that preserved underground facilities for decades, even when maintenance was, minimal. For contemporary builders, the lesson is clear. Combine multiple protective strategies to address every path water can take. Install continuous vapor barriers, reinforce critical areas with impermeable membranes, and disrupt capillary water movement beneath the foundation. This layered approach ensures long-term durability, reduces maintenance, and safeguards both people and equipment. Seeing how Cold War techniques can be applied today is pretty fascinating. While we may not face the same strategic threats as the Cold War era, moisture remains one of the greatest risks to underground construction. Root cellars, storm shelters, off-grid bunkers, and historical preservation projects all benefit from these principles. By studying the engineers who perfected vapor barriers, lead-lined membranes, and capillary breaks, modern builders can protect subterranean spaces against water intrusion. Practical steps include installing gravel and drainage layers under floors, using high-quality vapor membranes on all surfaces, and reinforcing sensitive areas with impermeable sheeting. The result is an underground space that remains dry, functional, and safe for decades. Cold War engineers proved that the most powerful defences aren't always visible. Their layered approach to moisture control saved entire underground facilities, demonstrating foresight, ingenuity, and meticulous planning. By applying these same principles today, we can build long-lasting, resilient underground structures that honour their legacy. If this exploration of Cold War engineering fascinated you, make sure to subscribe to Thermal Vault and share this video with anyone interested in forgotten technologies and practical history. These hidden techniques aren't just relics. They're lessons you can use to build smarter, safer, and longer-lasting underground spaces today.